So okay, let's start. Welcome to the track of the project quality today. The organizers aren't here. Thank you very much for the for contacting us and inviting us to this great event. The topic of this presentation is called Scaling Agile Projects with Proper Testing. So the focus is on Agile and testing and how we can combine those. I'm here with my colleague. We'll say some words about him later. We worked together on a project for a couple of years at Swiss Railroad, and these are real experience from the project that we made while implementing Agile processes and testing in this railroad project.
This is Marc Hoffmann. I probably hope you know him. If not, you should change it. In our project, he works as architect. Yeah.
Right. Marc Hinnen, Marc and Marc. This is very confusing, especially in the project, because we work together a lot.
We sit together.
He works as a product owner, Scrum product owner, for several teams, and has also a strong testing background. So he pushes us to actually take care about testing. Okay, let's maybe dive directly into the presentation.
Yeah, let's say. So if you're talking about scaling, what is scaling? For me, there are three types of scaling. First is amount of features. Second is complexity of your product. Technically, we'll go deeper later inside. And the third is the headcount. So we want to be practical, so we want to make examples with our project. So let's see what we work on.
Some context information. This is the actually application we're working on. It's railroad infrastructure. All European countries have immense amount of railroad infrastructure, and the traffic trains on this infrastructure has to be controlled. Even if there are timetables, there's real-time surveillance of trains and timetables and with forecasts and everything to control the traffic on the network. The network is, this is Swiss Railroad. This is where the project started in 2005, so nearly 10 years ago. This is how railroad networks are typically controlled nowadays. This is the railroad dispatcher, the lady. What you see here is part of our application, user interface. They see the traffic in real time, make decisions, adjust timetables, do decisions about how to fix delays, how to fix problems on the network. And there are 400 of these operators working 24/7, of course. While we are here, the user interfaces you see here, Eclipse based. Unfortunately, it's a little, we can change that, the light. It's actually pretty. We are already introduced the dark theme 5 years ago because this, the setups of the operators. These are very huge rooms with dimmed light, so that especially in the night they work 24 hours a 7. So the idea is, for whatever reason, that they use to work in a very dimmed environment, and so all the user interfaces are also on black background. And what we see here is graphical timetables. Basically, it's hard to recognize, but here are lines which are train paths. Like you have one dimension, which is the actual route, and the axis from top to bottom is the time, and each line is actually a particular train traveling through Switzerland. And we have like hundreds of these schemes and hundreds of these graphical schemes. The project has been started in 2005. It's actually not that big. It's just 1 million lines of code. The initial invest for the overall program was about 150 million euro, and we still run with more than 10 million euro a year for maintaining and developing the project. Currently, it's about. You can have more figures about scaling, right?
Yeah, let's look now at the scaling in our project. If you talk about features, I would say they're in the middle. It's really difficult to count features. What is a feature, what is the next feature? I can do 800 different features that are really separate. It has its own usability, its own techniques, its own architecture and stuff like that. So I would say there are other projects that are quite big. But if you look in team size, we are right now about 120 people. Not just developer, there are also, what do we have? Real users testing.
Domain experts.
Yeah, whatever. All the people around helping the developers can work on. But around 120 people is quite big to scale. And if we look about complexity, I would say we're something I've never seen before. It begins with stuff like performance. He said before that it's a real-time display. It's updated every second, the end-user display. It's high availability, 24/7. If it goes down for 10 minutes, it's a big disaster. So you just cannot, any fail in there is quite hard. The other thing is we have a lot in and out on the system. I know 20 by heart, and there probably become some more. And the whole system is data driven. So every special case that can happen happens. So it makes the code quite complicated. Yeah, that's about scaling. For scaling or for process, we use Scrum. Marc?
Yeah, we introduced Scrum in the project a couple of years ago in 2009. I think end 2009. We started 2010. We started implementing Scrum. It's the Agile methodology for the project. And this is for, I mean, there are other methodologies, but for this presentation, we focus on Scrum because this is where we made some experience. I will quickly summarize the Scrum process and see how testing is actually embedded or can be embedded with the Scrum process. This is an important diagram we use a lot. If you implement Scrum, don't start with leaving out certain parts of Scrum. So if you implement Scrum, just take the method like it is and really follow all the things given by the methodology from the very beginning until you really understood the Scrum process. So leaving out certain aspects from the very beginning is the major mistake, or the normal mistake, the main mistake when teams start implementing Scrum. But what you actually can do, you can put things on top of Scrum, like add additional rules, additional artifacts, whatever, and use the Scrum process as just as a framework. To describe the Scrum process, probably some of you are already familiar with that. You divide it in actually roles. You describe roles, you describe activities, and you describe artifacts. And the question is, how does testing reflect in the description of the Scrum process?
Roles. The main thing is the Scrum team. In the Scrum team, it's very important that your testers are in the Scrum team. Not like manufacturing, what I often see. The developer sits at his table, coding, then finish, work goes over, tester do his stuff. That's not teamwork. Teamwork is everyone in the team is involved in testing. The second thing, it's roles. It's not necessarily testers you need. It's just one in the team or some in the team that know what is the testing, the important part. There's a good example in the project we had. I guess about 2 years ago, we had one Scrum team with 3 testers, a lot more of developers, and suddenly, of course, some changes. There were all testers gone. The team were just developers, but it worked on. They took over the work. The work was done anyway. They learned they did everything testers did before. Just it's a role. It's not a person. It's not bound to them. The second thing is artifacts. Activities, sorry.
Activities. Activities describes actually the activities during the Scrum process. The loop, which is painted here, Scrum is called the sprint. For the sprint, we really recommend start with very short sprints. Like if you start implementing Scrum, start with 1 week or something like that. Because the most important aspect of Scrum is actually learning and improving the process. And if you have like sprints of 4 or 6 weeks, you get the learning and the feedback cycle every 4 or 6 weeks. So it's a very, very slow learning curve. But if you have like 1 or 2 weeks, so by default we have 2 weeks for all of the teams, you can adjust the process every 2 weeks. Speaking about activities within the Scrum process, testing starts at the very beginning, at the planning. The planning is when the team gathers at the beginning of the sprint and planning 1 or 2, there are some details, and the stories for the next sprint. And the first question is, if we accept a new feature from the as a user story, so the first question is, how do we actually test this? This is something that has to be answered from the very beginning. And as testing is part of the development process and part of the sprint, we also have to estimate. So how much time, money, whatever, you name it, is required to actually test this particular feature we are committing as a user story. During development, testing should also be involved from the very beginning. So test first is something what developers can do, like unit testing, test first, green, red, green, green, red, green, green, red, refactor. But test first can also apply to other kind of tests. Like you can, for example, create the test definition, test specification during the sprint before you even start coding. You can. We will see some examples later. We have formalized tests and formalized test specifications, actually executable test specifications. You can create these executable test specifications before you even start working on the feature. So testing is not something which happens after the fact. Like once the development team is done, we hand it over to the QA department. It's something which is implemented within the Scrum team. So every Scrum team, there's an artifact called definition of done, which is basically the rules of when is a particular user story done, and testing is part of the definition of done. Feature which is not tested is not done. You can't ship that. Another thing we learned is, especially if you work on a complex project, the pure Scrum methodology always talks about user stories in terms of user. So the end user can use a particular feature and he can click a button or has an input field. But for a complex system where a lot of algorithms are involved, it's sometimes very tough to write user stories like that. You probably know that. So you end up with writing technical stories. And you need to improve some algorithm, but there's no user interface to actually see the new algorithm. And what we learned is that actually testing, test cases, especially if you have executable test specifications, are very valuable to do demos. If you have good test specifications, I think about, like, we don't use that, but it's very well known as fit and fitness. If you can really show the test case and execute the test case, you can do nice demos for the end users. Even for user interface tests, I could imagine that, for example, with Joomla, you could run some test scenarios and just use that as a demo and to see how the new functionality actually works. And the test tools can be used in demos. This is what we learned.
Yeah, now, artifacts, the third part. First thing is product backlog items. Very important that I have good acceptance criteria. And with good acceptance criteria, I mean testable. From them, it's easy to follow what should you test, how do you test it. Then at the end, product. The product is not just code. It's also the test you implement, automated test. And that your regression tests are working. They're up and running. If you have broken tests, this product cannot be shipped. It's not ready. It's not the definition of done should allow. Other things like test cases, could even be manual test cases, it's part of the product. And even test reports. You can say, hey, customer, we did all that testing. It's ready here. And another thing is test tools. Sometimes you can't even test it. You need some helping tools to develop something to test it on a lower level or whatever. This is a test tool. It's part of the product. Yeah, now go to scaling and headcount.
Okay, scaling headcount is actually an issue if you try to apply the Scrum process. And this is our little Scrum team here. And we learned that the size of the Scrum team is actually crucial. And there's the upper bound. So we typically work with 6 engineers, 2 testers. One of the engineers also the architect of this group. There's a Scrum Master, maybe external or be part of the team. Maybe 10, but 10 for us is the maximum amount. If you put like 12 or 15 people in a Scrum team, the idea of self-organizing the team, it will not work out anymore. So if you scale a project, like in our case, you can't work with a single Scrum team. So what you do a bunch of Scrum teams, all with the same structure. In our case, it's 7 currently. 8 Scrum teams, different sizes. And now you need coordination between the Scrum teams. What you typically do is a Scrum of the product owners. So the product owner have like a master backlog and work on the master backlog and align the tasks from each team and make sure that, for example, the release in 1 year, all the activities are properly coordinated. And we have the same boards for every other role within the Scrum team. Again, it's a role, not person, role. Like the architects form the architecture board, so they align architecture decisions through all teams and also communicate architecture decisions or best practices back to the team. There's another board called delivery board. This is more about tools and about the daily problems of developers, like following best practices or not breaking the build or introducing some new tool. And the delivery board is typically formed by the Scrum Masters of the team. And now the important part, there's also a Scrum of testers. So all testers meet on a weekly basis, right? Meet on a weekly basis and talk about test issues. So partly they exchange their experience, but also they coordinate test efforts. For example, if you do release testing or acceptance testing of releases, it's not, it doesn't make any sense that every team actually tests all the features. So we can avoid redundancies if the testers of the teams coordinate each other and focus on special areas while executing, for example, acceptance tests. Okay, this is, I think, the only way how you actually scale headcount in Agile process. So don't try to put too many people in a single team. Just start splitting teams if they grow beyond 10 person per team.
Yeah, at some time we had teams of about 5 people, worked quite well.
Now let's go to the hard part, to actually
testing.
That's
the hard part, test properties, yeah. Still, I hope you still remember that the 3 dimensions I had of scaling, number of features, complexity, and headcount. If you scale in features, it's crucial that your tests are fast. The more features you build in, the longer it takes, that will break your neck. It's also important that your tests are easy maintainable. You probably understand it quite easily because more features make it harder to. Another thing is the low setup costs. If every feature test needs another setup cost, it increases, won't go very well. And the fourth thing with features, let me say, is high test automation. So if you have manual tests and you increase, won't work very well. We experienced that by heart. The other thing, I said complexity. If you scale in complexity, it's important that your tests are highly automated. Second thing is the integration. If you have a complex system and you have your unit test about the unit A and the unit B, and everything is green because each unit is working well. In a complex system, you don't know if they work together. So it's very important that you have a lot of tests that checks the integration at system level, checks the whole thing. And the third is headcount. If you have a lot of people, like we have right now, and your build takes about half an hour, a lot of other developers have already checked in other stuff. And the broken thing then to revert it, it's really important that your tests are fast. It's also maintainability, because if one creates a test and the other don't even understand what you have to do to maintain it, not that good. And the third is the low setup costs. If you need test environments for your tests, stuff like that, and you increase teams, and every team needs a new environment, that could get quite expensive. Yeah.
There are different kind of test implementations, how you can actually implement tests. This is just a series of examples. We picked it because we do exactly these kind of tests. And I just want to give you some ideas about these kind of tests. And we glue it all together afterwards. Unit tests. I mean, you all know what unit tests are. they are isolated, they run fast, and they are typically created by developers. For me personally, I'm a software architect and come from software quality, especially inner quality. For me, the main point about unit tests is actually validated design on a unit level. Like, because if you write the unit test, you are the first user of the API of a small component of your unit. You think about, okay, does this make sense? It has a method, a proper name. Is the return type in every situation defined? You also fix your dependencies. Because if you write unit tests from the very beginning, you do test first, you will see if you get a mess with your dependencies. Unit testing is not fun. So for me, the primary purpose of unit testing is actually fix the design from the very beginning. Second point is, okay, prove the initial correctness of the unit, and third thing is, of course, enable refactoring in the long run. We introduced also something like component tests. If you build a complex system, you can't just pick the single units. You have like huge building blocks. Like for the, let's say, in our example for the railroad, there's a forecast component. The forecast component has lots of business logic to actually forecast the train run for every train. So when will the train arrive in a particular station, when will it depart, and so on. And for this kind of components consist of many units, and even if you tested the units separately, you still don't know how the whole component works. And you want to have a different level of abstraction. You really want to describe the test in a language more on a business side. Like, there's some business logic in there, and you really want to see, okay, if the situation is like that, if trains arrive like that, then the forecast should look like that. And for this, we developed kind of a small component test framework, data-driven component test framework. We actually use Excel. This is a screenshot of Excel sheets. And this is this test specification. Basically, every line is a test case, and you see some expected values at the green bar on the right. And these tests are partly maintained by the developers, but they are mainly developed by the testers. And also, we do these tests with the business analysts and even with the end users. So we talk about scenarios, and we talk about expectations, how the system should behave in certain situations, and we can formulate this with the Excel sheets and use this as a test specification. Again, we can do this test first. So we can write this specification before we even start changing a feature or adding a new feature to this particular component. It's still, it's very human readable. So the coloring, you can add colors, you can add comments, you can add descriptions to the test case. Excel is actually a pretty powerful tool for that. Like unit, actually we use JUnit as a test driver, but it's not unit testing. We're not talking about unit testing here, to make that clear. But it still is very fast. So if you isolate the component, if you don't need database requests and things like that in the background, then these still execute very fast, and they can still do it in the continuous integration. There's more tests.
Yeah, above that we do some automated system testing. Oh yeah, that naming is because it's system test automated. We're not going with funny names. But the thing of it is we test the whole system under test completely. That's system level testing. For that, you just adapt everything and you test. We go below the GUI layer. So it's just a check on the API layer. That makes it much more maintainable, much more easy to keep it alive. But for that, you need a full environment to run. Like I said before, it can get expensive. And above that, we do some GUI testing and manual testing. In the GUI testing, the stuff it's slow, and it's slow in execution, and if you have a failure, it's very hard, it takes a long time to fail the cause. Because if your unit fails, the unit test fails, you know, there is a failure. But if your system test fails, you just know the system is broken, but I don't know where. And usually if it takes if it's slow, you don't know which revision, which change was causing the problem. As you've seen in the beginning, we have quite complex GUIs. So we need a lot of GUI testing. So this, cutting the GUI before was a good way to do it in the system level, but we need a lot of GUI testing. And for that, we need up and running a lot of test environments. And for getting that, we need some tools.
to actually implement all these kind of testing, you really have to make sure you have a tool stack to support Agile projects. This starts with continuous integration. Continuous integration is the foundation for unit testing and component testing. If the unit tests are not executed automatically on a very aggressively regulated base, they will degrade immediately. I mean, if you think about 1 million lines of code, there's somewhere around, not too much, but maybe 100,000 or 50,000 unit tests. But nobody can oversee this amount of tests. So if they are not executed, like every 20 minutes or something like that, the system will, the test set will degrade immediately if 60 engineers work on the same system. The same for the component tests. Luckily, the component tests work very fast, so we can still execute them in the continuous integration environment. The other thing is continuous deployment. Really take that seriously. I just recently have seen a team, they did Scrum, like 2-week sprints, but they deployed the system every 6 weeks or something like that. How should that work? And they did not even release their first release, but they have a huge pile of bugs already because they do testing after the fact, and the development team can't fix the bugs because they are busy with developing new features. I mean, this project is really screwed up. And so really take this serious, and from the very beginning start with continuous deployment. And if you have continuous deployment, you can add the other test implementations on top of it. You can use system test automation because you have a deployed system and you can run the system test automation every night. You can run manual user interface test or automated user interface test because the users have a running system all the time available with the latest and greatest version, but the development currently does. And both, yeah, for automated and manual testing. So the tool stack is really crucial before you even start thinking about testing. So because sometimes you miss that and think about test tools, and this is the wrong way around.
Just a second. I just want to mention our continuous integration feedback. Since we're working for railroads,
yeah, okay. I should mention that. This is the adequate feedback device. This is a Swiss Railroad light. We have them in the office too, so we know actually what we're working on. It's currently green, everything, so it took me some time to find a point in time to take that photo. No, it's not that bad. Yeah.
Okay, let's go back to our test properties. I hope you remember the 5 test properties I mentioned before. Now look at the 5 types of tests we have. The unit tests we have, they're fast in execution, they're easy maintainable, they have low setup costs, and they're highly automated. It's mostly the same with the component tests we have. But some component tests do need some part of integration tests. Only that some integrating a little bit. If you go to system test automation we have, they're definitely not fast. And they need an environment, so we have setup costs. They're a bit maintainable compared to other things because they have no GUI access, but they're highly automated and they're integrating the whole thing. And the GUI automation we have, they're definitely slow and a lot of maintain costs, but they're still high automated and to do whole system integration testing. And with the manual testing we do, I don't have to explain much, it's just integrating the whole thing. So now let's cross these 2 tables I show you. If you scale in features, that means you need unit tests and you need component tests. If you scale in complexity, that means you need some system test automation and GUI test automation. And if you scale in headcount, you need, similar to features, unit tests and component tests. And manual tests you don't need at all for scaling.
We still do, of course. But we all know, and you can really derive that if you look at the test properties, that manual testing does not scale in any of the directions. And this is nice if you combine these properties. This is what you just can mathematically figure out. And you can also see it in the project. Another practice we learned is important to implement is test metrics. Like really make sure, especially if you're working in a huge organization, make sure you have your test metrics. You keep an eye on your test metrics. I mean, it sounds so obvious, but you really should make sure that you have red lights all over the place for the test success and the test success rate. It's very easy to overlook failed test cases. And let the test suite or the system degrade over time if you don't take care about regressions in time, especially like system test automation, like Marc told us. If you test the overall system and in an all integrated way, and if one of the tests failed, and you have a change set of, let's say, 1,000 commits, it's so hard to tell what was actually the cause for the problem. So having a timely feedback on test metrics and the success rate of the test is very, very important. One thing, of course, I have to say is code coverage. Keep an eye on code coverage. My recommendation, forget about percentage. Don't care about 70, 80, whatever percent. It's not an objective at all. From time to time, look at the code which is not covered at all. This is the only point, and the only useful point. Because covered code just means it has been executed. Does not mean it's correct or right or whatever. So the only thing you can say about uncovered code is it has not been tested or it's useless. It's just that code. So, and then you can react on that. Like create more tests for that, or create tests for this uncovered code at all, or just remove it if it turns out that it's that code and this is worthless. If you have some tooling, you might observe functional coverage. If you use some ALM tool, you might be able to connect your test cases to features, and if you execute, for example, in a release test, the test cases, you can see how your features are actually covered. And one important thing when we talk about scaling is also execution time. Really keep an eye on execution time of the test. Let's take, for example, unit testing. The unit testing run in the continuous integration environment, we just learned feedback cycles is really, really important. You have like 60 people continuously committing on the code base. It's very important to get fast feedback. And what we experienced in the past, that the concept of unit testing is not very well understood all the time. And so you end up with unit tests having like a little sleep in there to wait for some thread, whatever. This happens. It even happens in our project. And then this is a nice pattern, and so it seems to work. So what you do, code reuse, copy and paste, right? Create a couple of these unit tests, and during the time, the unit tests, maybe at the beginning they were like 5 minutes, and now they are 6, 8, 10, 15 minutes, and all of a sudden the whole build is like 40 minutes or something like that, and you break the fast feedback cycle of the continuous integration. The same is for the system test, and even the same is for manual testing. Even there, for whatever reason in your organization, we have like in the peaks like 10 end users working on the manual tests, and sometimes we simply fail to execute the tests in a given time frame. And if you realize this fact at the very end of the testing period, you're screwed. So you should have a tool to actually monitor the progress of the manual test execution during the test phase, so you can create countermeasures like finding the root cause, because why do for this release the test not progress as fast as expected? Or maybe we don't have enough test resources from the end users available. So really keep an eye on the execution time, from the tiny units like unit testing to the huge time scale like manual testing when you do release tests.
Yeah, just measure it, that's the important part, because
one
day a project manager came to me and asked, will it scale if you double? I want to do a new project, you just found 50 million and said, I want to do a cool thing. Will it measure? And I said, oh, I don't know.
Okay.
It's really not that you know. So we're a little late in time. This is our giveaway for you to take it home. Some kind of a checklist that you can see. Do you do the right stuff to be ready to scaling? We have organizational tooling and test implementation things. I will just fly over because it's the last minute. Be sure you have the testers in your team. Be sure you test first on any level. Be sure the testing is in the definition of done. And Scrum, like stuff you do if you have head scaling. Then continuous integration, you probably all know very well, but continuous deployment is one of the crucial things you have. Be sure that your testing keeps alive. That's metric we just had, and the testing implementation, be sure that you have every level. Like Marc said before, some years ago we didn't have the component test, and we struggled. We couldn't go any farther because we had system tests and unit tests. They were slow, they were fast, and we didn't know.
Something was missing in between, yeah.
Genau.
And we couldn't cover the...
This month we said, cool. And this solved a lot of problems for us. So, thank you very much.
Maybe we can pick one question.
You mentioned automated unit tests.
Right.
I have two questions. What kind of tools are you using? Are these custom tools you implement yourself? Or?
No, actually we are on QuickTime. HB Quality Center, quick test.
Okay. And are they executed in the continuous integration cycle? Or
No.
Are they executed?
They require actually physical installations on the systems.
We have a nightly run of them.
Okay.
But
the setup cost is pretty expensive. You really need physical boxes to install the stuff.
So two questions. First is you're saying that you have you test everything within the team. So you have 8 Scrum teams. So how do you test those interdependencies within those teams?
Okay, there's something. There's something we call them. What they call it? 6 weeks.
The
iteration tests. We have the iteration test phase where we do cross testing every 6 weeks. So it's after 3 sprints. This is in addition to the. It is actually pretty likely, and sometimes happens that one team breaks the functionality of the other team. This happens, yes.
So, but that's not the part of your definition of done. So the features are done.
For the team, of course we try to avoid this, but the cross-testing is very important. And you would love to have the system test automation cover all the functional aspects of the system, but we're not there.
And in this case, they're all coming to what the testers or people with the role of testing come together from those 8 Scrum teams and they test together, or?
No, they just coordinate. They just coordinate each other.
For example, we do every week smoke testing about non-functional things, and the 8 is Scrum organization. Who will do it? So you don't have redundancy and do it double work, stuff like that. So we do continuous testing on every week, but just every you need Scrum to be sure who's doing it.
Like one team says, okay, we have some capacity, we can do the NFR test this week or something like that.
Okay, that touches my second question, because you have the Scrum of tests, and in my experience it's quite problematic to actually coordinate this. If you just said, well, we just coordinate. But
there's
is
some
that a problem for you? I mean,
there's actually a person in charge. We have a test manager who is actually also the head of the Scrum of testers, and he's in charge of making all the coordination. It's not really fully self-organized, so there's one person in charge to make sure that this process works.
For all teams.
Yeah, he does not show up in the teams, individual teams, but now we have to stop. But we are around overnight, and we will have a couple of beers probably at the band tonight, right?